Okay, let's unpack this.
Let's do it.
Today, we are strapping in for what might be one of the most uh, conceptually dense, just wildly interdisciplinary deep dives we have ever attempted.
That is not an exaggeration.
No. If you've ever thought computer science was purely technical, just circuits and code, prepare for a cosmic revelation. We are cracking open a really singular text.
A very singular text.
It's called The Legend Mind, Zero to Infinity, by an author who goes by the ESKR, which is Sonu Kumar. And our whole focus today is on one chapter, chapter 27, titled simply Computer Basic Rules.
And that title is, I think, intentionally misleading. It sounds so simple.
Right. You hear that and you expect, I don't know, a standard, dry computer science lecture on Boolean algebra or maybe logic gates, something like that.
Yeah, the fundamentals.
Think again. The book's grand mission, and this is according to its own preface, is nothing less than an eye-opening quest.
It's a quest.
A quest to understand mind power, spiritual wisdom, and to answer, and I'm quoting here, the most striking, curious questions by following a really radical interdisciplinary approach.
And when he says interdisciplinary, he means it. He's throwing everything into the same philosophical melting pot. Science, mathematics, religion, physics, cosmology, social studies. It's all in there.
It really is an attempt at a unified theory of everything, but it's anchored in this very deep spiritual journey.
And that's the key, I think. What's so fascinating here is that the foundation of this work isn't academic in the traditional sense. It is intensely spiritual and personal.
How so?
Well, the author dedicates the entire book to my immortal guru, the Lord Shiva. And he explains that the inspiration for this massive undertaking, this entire book, came directly from watching the gods roll on television.
Wow.
Yeah. And this pursuit, this vision, it drove the author to adopt a solitary existence, to live alone with, quote, zero attraction of the world.
So this context is everything. We aren't just reading a theory, we're looking at a codified spiritual vision.
Precisely. And this vision, it's held together by the author's powerful, repeating philosophical motto. It's an acronym. LEGEND.
Oh, right, the acronym. I find this part fascinating.
It is. It stands for Legacy, Even God and Not Demons.
Legacy, even God and not demons.
That's the core framework. It's all about the eternal struggle, the enduring truth, the defining context of existence itself. So our mission today, our deep dive, is to analyze exactly how this ambitious philosophical and spiritual framework manages to merge with the nuts and bolts of the modern digital age.
We're going to scrutinize Chapter 27's concept of computer basic rules, not just as technical code, but as a window.
A window into a much deeper cosmic classification system, a system that the author claims defines everything, from our social order all the way up to the operational rules of entire universes.
Okay, so to really appreciate the sheer weight of Chapter 27, we have to place it right. We have to situate it within the larger philosophical architecture of the book, of The Legend Mind.
It doesn't stand alone.
Not at all. The book is structured across multiple units, and this chapter, it falls specifically under Unit 2, which the author calls The Legend Unique Questions.
And that unit has a very specific purpose.
It does, and we have to understand that purpose because it's the engine of application for the whole text. It takes this really personal foundation that's laid in Unit 0, which is all about self, soul, and mind awareness.
That's internal stuff.
The internal stuff, exactly. And it combines that with Unit 1, which is called the observational unit of professions. So you have the internal and the external.
And Unit 2 is where they meet.
Exactly. Unit 2 applies these foundations directly to internal growth, to self-enlightenment, and to wisdom. This is where the abstract awareness of the self is supposed to generate these tangible, universal answers. It is like the unit of discovery.
And the scope of these discoveries, these questions, it's utterly exhaustive. I mean, the list of unique questions posed in Unit 2, it reads like a summary of humanity's most persistent mysteries.
Like what? Give us a taste.
Well, for starters, we are talking about mapping the basic calendar of humankind, calculating the value of infinity, and decoding Earth construction and prediction. And on top of that, proposing two massive new cosmological models.
Two of them.
Two. First, there's the I theory, which offers this unique explanation for the origin of the universe.
The I theory, what does that even imply?
Well, the author doesn't go into detail in our chapter, but just conceptually, the name itself suggests a singular point of observation, right? A cosmic lens or maybe a focal point through which all creation originates. It implies a direct observant source for existence.
Almost like the universe is being watched into existence.
That's one way to think about it, yeah. And then you have the bead theory for the parallel universe concept.
Okay, the bead theory. That one immediately conjures an image for me.
What do you see?
I see multiple universes kind of strung together like beads on a cosmic chain or a necklace. It suggests a sequential or connected arrangement, not just these infinite separate bubbles floating around.
And that's it. Understanding that the author is tackling questions of this magnitude, I mean, the literal origin of reality and the structure of parallel dimensions, it tells you the kind of weight they assign to the smaller, seemingly mundane questions.
Like the structure of binary code.
Precisely. Other questions in Unit 2 include things like the universe movement theory, figuring out where aliens' home stars are, the concept of three worlds, and these really foundational philosophical queries like the story of digits and the spiritual role of 1 and 0.
So Chapter 27, Computer Basic Rules, it's presented not as some standalone analysis of tech, but as one crucial piece in this sprawling universal puzzle of constants and codes.
It's one bead on the string.
I like that. It's a staggering inventory of cosmic and mathematical mysteries. But here's the interesting part, and I want to get your take on this. The author is simultaneously incredibly ambitious and almost modest about all this.
I know exactly what you mean.
They are very clear that these questions are presented, quote, in rough way or big picture, not in perfect way. This isn't meant to be the final answer. It's a sketch.
And that humility, I think it's actually a genius strategic maneuver. By stating that the work is not perfect, the author frames the text as a conceptual blueprint. It's a challenge, or maybe a puzzle box for us to open.
The implication being that the lack of perfection is deliberate.
I think so. It leaves these gaps for professional engagement. It's an invitation.
So instead of saying, I have solved cosmology, here's the answer, the author's actually saying, here are the philosophical clues. Now, you, the professional.
It's your turn. Exactly.
Oh.
This invites the global community of experts, the scientists, the astrologists, the mathematicians, the computer engineers, the physicists. It invites them to go deep in this question to get perfect results.
So the text becomes a launch pad.
It's a conceptual launch pad, providing the spiritual and mathematical frameworks that they believe are needed to arrive at, quote, better knowledge. It forces experts in these highly specialized siloed fields to engage with an interdisciplinary text that's rooted in spirituality.
You know, the whole narrative structure of the book itself is compelling when you put it that way. It's like a movie. You have a hermit, inspired by a deity, who provides a series of profound riddles to the world's greatest minds. And the key to the riddles is this combination of ancient philosophy and modern computing.
That's a perfect way to frame it. And it sets the stage for our deep dive today. We are dealing with a set of principles that claim to unify spiritual truth with foundational computer logic.
So let's take that promised deep swim. Let's examine the very core of our modern technology through this revolutionary philosophical lens, starting with the nature of the 0 and the 1.
Let's do it.
Okay, let's jump right into Chapter 27 proper. We all live immersed in the digital era, right? We know that the computer understands only binary language.
0 means off, 1 means on.
That's the established consensus. But the author immediately pivots. He poses this core puzzle. We know what binary is, but, quote, we don't know how it works as a part of operation.
It's the mechanism behind the calculation.
Yeah.
The operational philosophy. That's what we ignore.
And this is where the author introduces a concept that just radically redefines digital structure. They state that binary language isn't a neutral system of on and off.
No, it's a system that's imbued with charge. It's split into two families, both of which are combinations of 0 and 1.
Two families.
You have the positive binary language family, and you have the negative binary language family.
Okay, positive and negative families. But the critical claim here, and get this, is that what determines if a bit stream, a string of 1s and 0s, is positive or negative is not a designated sign bit, which is how we do it in conventional computer science.
Right.
Instead, it's solely the specific arrangement of 0s and 1s in which they are placed.
The positional structure itself. That alone defines the charge.
That's a huge assertion. I mean, in standard computer science, we often use things like 1's complement or 2's complement to represent negative numbers. Or, we just dedicate the most significant bit, the leftmost one, as a sign indicator. 1 for negative, 0 for positive.
The standard way.
Here, the author is claiming the intrinsic arrangement over the full length of the binary word defines its charge, which means we have to look at the specific chart provided in the source material. It's a 4-bit chart covering the range from 0 to 15.
And we have to analyze this structure meticulously. Let's start with the lower range, from 0 to 7, because that's where the patterns are most clearly sort of inverted.
Okay, let's start at the beginning. 0.
We begin with 0. Positive 0, which he writes as plus 0, is represented by 4 zeros. 0, 0, 0, 0.
That makes sense.
But then negative 0, or negative 0, is represented by 4 ones. 11, 11, 11. So right away, this establishes the fundamental duality, the two poles.
Okay. And then when we move to plus 1, that's encoded as 0, 0, 0, 1.
And its negative counterpart, mag 1, is 11, 10.
So we are seeing a perfect mirror image here. In every single position, the digit is just flipped.
It is. And notice, for this range, from 0 to 7, notice how the leading bit, the leftmost digit, is consistently 0 for all the positive values.
Right. Plus 0, plus 1, all the way to plus 7 start with a 0.
And for all the corresponding negative values, they start with a 1. This is where that initial segregation, that sorting into the two families, happens.
Okay, let's skip ahead a little. What about, say, plus 4?
Okay, plus 4 is 0, 1, 0, 0. And if we follow that mirror principle, its negative family counterpart, negative 4, is 10, 11.
The pattern holds perfectly. 0 becomes 1, 1 becomes 0, 0 becomes 1, 0 becomes 1.
It holds. And if we were looking at this solely through the lens of standard computing, you might just call this the ones complement, where you simply invert all the bits to find the negative.
It looks exactly like that.
It looks like it, yes. But the author frames it simply as a difference in arrangement, not as a complementary operation. And this subtle difference in framing is key, because the rules for using these arrangements, which we're going to get to, are entirely unique.
Okay, so it's not the operation of inverting, it's the state of being arranged differently.
That's the idea. Now look at the boundary of this first set. Plus 7 is 0, 1, 11.
3 ones.
And its negative complement, negative 7, is 20,000. So again, the positive sequence maintains that leading 0, and the negative sequence maintains the leading 1.
This defines segregation by positional arrangement. It feels like the absolute foundational principle for the arithmetic rules that have to follow.
It has to be. If the computer can't accurately recognize these two families based purely on the string of zeros and ones, the entire computational mechanism that he proposes, it fails.
It all falls apart.
Now let's explore what happens at the crossover point, when we move from 7 up to 8 and then on to 15. This is where that simple rule of leading 0 is positive completely breaks down.
And this, I guess, confirms that the structure is determined by the full 4-bit constraint, not just the first digit.
Exactly. So for plus 8, the positive sequence itself flips. It's represented as 1,000.
Whoa! Okay, so suddenly the positive value begins with a 1. If a computer only looked at that first bit as a sign bit, it would read this as negative in many conventional systems.
Absolutely. This requires a much deeper reading of the entire arrangement, and consequently, many take 8 flips to begin with a 0. It's encoded as 011.
Which was the code for plus 7.
Which was the code for plus 7. The relationship remains complementary, but that initial bit designation is completely reversed compared to the 07 range.
Okay, so this shift confirms that the designation of positive or negative isn't determined by a single dedicated sign bit. It can't be.
It can't. It's determined by the overall pattern, which is dictated by the system's limits. The patterns are designed to maintain their distinct separation throughout the entire cycle, from 0 to 15.
And this pattern continues all the way up to the maximum value that you can represent with 4 bits, which is 15. So plus 15 is represented by 4 ones. 11, 11.
And mirroring this, to complete the cycle, negative 15 returns to 4 zeros. 0, 0, 0, 0.
So zeros is 11, 11, and plus 15 is 11, 11, and plus 0 is 0, 0, 0, 0, and negative 15 is 0, 0, 0. So the circle closes.
The circle closes. And the significance check here is paramount. We need to really understand this in that movie-style sense you mentioned earlier. This is the hidden coding structure. This is the blueprint for digital reality in this system.
It's the matrix code, basically.
It is. The author is asserting that these specific, distinct arrangements are not just arbitrary codes we made up. They are deterministic structures that define the very nature of positive versus negative number computation within the computer. The machine isn't just reading on or off. It's reading arrangements that carry an intrinsic positive or negative value.
And this data, this input, is what defines the nature of the calculation that's about to happen.
Exactly. It's almost as if the author is claiming that the charge of the number, its positivity or negativity, is encoded into the very fabric of the binary arrangement itself, independent of any external sign indicators. The entire system is built upon this specific, codified symmetry and inversion across the 4-bit spectrum.
All right, so now that we've established the existence of these two binary families, the positive and the negative, defined by their unique arrangement, we have to move to the operational rules.
This is where it gets really strange.
This is where the author makes the most radical claim about how the computer actually performs calculations. He states it's based entirely on a system of axiomatic subtraction.
It's a very specific kind of subtraction.
Here's where it gets really interesting. The theory posits two specific, and I have to say, non-traditional subtraction operations between 1 and 0 that, according to this source, govern all computer functions.
All of them.
Okay, let's lay them out. Rule number 1 is 0, 1, 1 equals 0.
Let's just pause on that for a second.
Yeah. And the justification provided for this is philosophical. It's not algebraic. The justification is 0 is greater than -1, 0 first one.
Okay, this is the note we have to pause. From a standard mathematical perspective, that is not how subtraction works. 0 minus 1 is -1, period.
Yeah, right.
The author is deliberately, it seems, sidestepping the conventional definition of negative numbers that arise in this operation. You have to call this out.
I have to challenge this. Rule 1, 0, 1 is 0, 1 is justified because 0 had a 1. That definition completely sidesteps the need for the number -1 itself to even exist as a result of the calculation. If the computer is built on this axiom, how does the author account for the fact that this is a fundamental rejection of a basic arithmetic result? This isn't just computer science anymore. This is a radical redefinition of arithmetic logic itself.
And that is precisely the point. The author is not claiming that these are the rules of universal mathematics that apply everywhere. He is claiming these are the internal, axiomatic, basic rules of the computer's operation, specifically within the closed system of the positive and negative binary families he just defined.
So it's a closed loop. Inside this box, these are the rules.
It's a closed loop. Within this system, the computer must adhere to these two rules to arrive at the correct positive binary result. The fact that the justification is 0 to 1 shows that the logic is constrained by the relationship between the 0 and the negative value of the 1 being subtracted, rather than the arithmetic result being carried over. It's an instruction set, not a universal algebraic statement.
Okay, I can accept that. For the purposes of this system, it's a mechanism designed to produce a required binary output, even if the intermediate step defies standard math. It's the logic of this specific machine.
Exactly. And the second rule is much more intuitive.
What's that one?
Rule 2, 1, 0 equals 1. The justification provided is also axiomatic. 1 is greater than 0. 1, 0.
Okay, that one doesn't break my brain. So these two rules, operating as the machine's fundamental instruction set, they are the key to the author's entire computational model.
They are, and they're used to prove that the computer arrives at a target value, let's call it n, by subtracting its negative binary representation from its positive binary representation.
So the formula, which is applied digit by digit, strictly following only Rule 1 and Rule 2, is n plus n Nash n.
And we have to walk through the application of these rules. We need to see this complex movie scene play out in detail to prove the system's internal consistency. We are essentially subtracting the binary codes we just established in the last section.
All right, let's do the math. Where do we start?
We begin with the base case, 0, 1. The formula is 0 lion plus 0 equals 0, using the code set 0, 0, 0, 0, 1, 1, 1, 1.
Okay, so for every digit, we're doing 0 minus 1.
And according to Rule 1, which says 0, 1 equals 0, the result for every single position is 0.
Which gives us 0, 0, 0, 0.
Which is the codified positive binary language for 0. The system holds up for the starting point.
Okay, that was easy. Now let's try 1. This should be the real operational proof because it's going to force us to use both rules.
They go.
The formula is 1 plus 1 minus 1. The codes are 0, 0, 0, 1, 1, 1, 1.
Right, so we break it down position by position, left to right.
Okay, first position, the leftmost one, 0 minus 1. By Rule 1, that equals 0.
Second position, 0 minus 1.
Again.
Rule 1 gives us 0, 3.
Third position, 0 minus 1. Still Rule 1, still 0.
And the last position, the rightmost one, 1 minus 0.
And for that, we use Rule 2, which says that equals 1. So the final result is 0, 0, 0, 0. The precise positive binary code for 1. It works perfectly. I mean, within this axiomatic closed system, it's flawless.
Let's test 2, just to be sure. We need its codes. Plus 2 is 0, 0, 1, 0, and negative 2 is 11, 0, 1.
So 2 equals plus 2 and negative 2, which is 0, 0, 1, 0. 1, 1 again. So that's 0, 1.
Third position is 0, 1. Third position is 0, 1. Rule 1 again, so that's 0.
Third position is 0. Rule 2 gives us 1.
And the fourth and final position is 0, 1. Back to Rule 1, giving us 0. The result is 0, 0, 1, 0. And again, that's the correct positive binary code for 2. The author's claim mechanism is, as you said, internally consistent. It works based on the defined binary arrangements and those two subtraction axioms.
Let's try one more, just to be thorough. What about 4? just to ensure the pattern holds when there are more ones involved in different positions.
Good idea. Plus 4 is 0, 100, and minus 4 is 0, 1, 1.
Okay, so 4 is 0, 1, 0, 0. Let's break down the 4 positions.
Go for it.
Position 1, leftmost, 0, 1. By rule 1, that's 0. Position 2, 1, 0. By rule 2, that's 1. Position 3, 0, 1. By rule 1, that's 0. And position 4, rightmost, 0, 1. Rule 1 again, that's 0. The result is 0, 1, 0, 0, which is precisely the positive binary code for 4. The math holds.
It does. Now let's jump to a high number. Let's do 8. This is a crucial test because this is where the codes themselves flipped in the last section. Remember, plus 8 is 1,000 and minus 8 is 0, 1, 1.
Right. The positive number now starts with a 1.
So the equation is 8 plus 8, able to 8, which is 1, 0, 0, 0, 1, 1, 1.
Okay, let's do it. Position 1, leftmost, 1, 0. Rule 2 gives us 1.
Position 2, 0, 1. Rule 1 gives us 0, 1.
Position 3, 0, 1. Rule 1 gives us 0, 1.
Rule 1 again gives us 0.
The result is 1, 0, 0, 0, 0.
This consistency is remarkable. It demonstrates that regardless of whether the positive number starts with a 0 or a 1, the subtraction operation between the defined families always yields the correct positive code, using only these two specialized subtraction rules.
And the source material stresses that if you, and I quote, continue till 15, which we know is the maximum 4-bit value, the result is always the codified value in the positive binary language.
Should we do 15 just to close the loop?
Let's do it. Plus 15 is 11, 11, and negative 15 is 0, 0, 0, 0, 0. So 15 plus 15 is 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0.
Well, that's easy enough.
Yeah. Since every position is 1 minus 0, which by rule 2 equals 1, the result is just 1, 1, 1, 1. The process is verified across the entire spectrum.
And this synthesis is crucial. The author is arguing that the entire operation of calculation, the engine of the computer, is defined here as a pure, structured subtraction process. All the complexity we see is managed by simply encoding the number into its positive and negative family arrangements, and the computation is just the simple act of subtraction between the two families using just those two rules.
Okay, the successful mathematical demonstration, it leads us directly back to the most critical why question that the author poses. Why does the computer follow only the subtraction rule between 0 and 1, interchanging its place for performing the operation behind the computer? Why subtraction? Why not addition or multiplication or division?
And that's the pivot.
It is. We've just spent a significant amount of time proving the internal mathematical consistency of the author's claims. It is, in its own way, an engineering masterpiece of abstract thought. But now we pivot. We're about to jump from proving a binary operation to reflecting on the magnitude of jumping from that consistent math axiom to a universal classification system.
Why does this technical mechanism, this subtraction engine, govern our digital lives?
This is the pivot point that takes us from computer science directly into metaphysics and spiritual alignment.
To answer that why subtraction question, the author introduces a philosophical categorization of the 4 basic mathematical operations: addition, subtraction, multiplication, and division. And he assigns them to different cosmic or social entities based on their perceived nature.
This is the ultimate connection. This is the bridge between the digital world and the spiritual cosmos.
It is. This assignment is the core of the metaphysical connection. Let's just lay out the framework clearly.
Yeah.
First, multiplication, the X symbol, belongs to the guru.
Guru gets multiplication.
Got it. Second, addition, the plus symbol, belongs to God.
Okay, God is addition.
Third, subtraction, the X symbol, belongs to human.
And that's us. That's the key.
That's the key. And fourth, division, the X symbol, belongs to the demon.
Okay, so if the computer we use, our technology, runs perfectly on the rules of subtraction, which we just spent all that time proving, then by the author's logic, that must be because our Earth as home of humankind followed the subtraction rule.
The tool matches the user.
Exactly. The entire working of our computer language, our binary language, must therefore be fundamentally governed by subtraction between 0 and 1.
But let's unpack the philosophical claim here a bit more. Why subtraction for humanity? What is it about that operation?
Well, subtraction, at its core, it relates to loss, gain, debt, exchange. Our lives are defined by the difference between what we have and what we want, or what we gain versus what we lose. That feels very human.
It does, and it aligns perfectly with the author's later social classification. If you look at the social correspondence for the human class, he links it to the Vaishya, or business class.
The merchants, the traders.
Right, associated with trade, commerce, and production. Their entire existence is predicated on balancing ledgers, calculating profits, managing deficits. Life on Earth, particularly the transactional human experience, is a constant process of defining boundaries and calculating differences. That is fundamentally the realm of subtraction. Our reality is a dynamic equation of giving and taking.
And when you contrast this with the other operations, it really clicks.
How so?
Well, addition, belonging to God, implies infinite potential, creation, absolute plenitude. It's the act of bringing together and increasing without any limit.
Pure creation.
Pure creation. Then multiplication, belonging to the guru, that implies the exponential growth of knowledge and wisdom. The ability to propagate concepts across many minds from a single source, a single teaching.
And division.
Division, belonging to the demon, suggests breaking apart, separation, the fracturing of unity into disparate warring pieces. It's entropy, in a way.
It's dizzying to think our entire digital world, from the most complex algorithms to our banking systems, from social media to artificial intelligence, is all defined by the mathematics of the transactional human class, the subtraction operator.
It suggests that if a computer were built by a guru, it might operate primarily on multiplication rules.
Or if it were built by a demon, it might rely on division as its core computational principle.
Different entities must have their own digital worlds based on their associated mathematical operation, and that would lead to vastly different basic computer rules.
We can go even deeper. The author assigns a structural classification based on the very first few positive binary numbers themselves. This provides a digital structure, a blueprint for each group. This goes beyond just the operation. This is the core binary signature of their existence.
Okay, so let's detail the first 4 positive binary arrangements and their corresponding classification.
Let's do it. Group 1, Guru. The assigned binary is 0000. The operational focus is on 2 zeros, which he represents as 000.
Okay, and the social correspondence.
The Brahmin, or priest class, traditionally associated with knowledge, detachment, spiritual guidance, the 0-0 focus seems to imply a state of pure potential or non-action, where wisdom is multiplied rather than physically exchanged or created, the void from which knowledge grows.
That makes sense. Okay, group 2, God, assigned binary, 00001. The focus here is on 0 and 1, represented as 0-1.
And this corresponds to the Kshatriya, or ruler class. They're associated with governance, protection, maintaining order. And you can see the symbolism, the combination of nothingness, 0, and unity, 1, to form the basis of all physical reality. They're adding to existence.
Right. From the void comes the 1, the act of creation.
Exactly. Now, group 3, human. Assigned binary, 000, which we know is the code for +2 in decimal. The crucial focus here is on 1 and 0, represented as 10.
And this corresponds to the Vaishya, or business class, the traders and producers.
And that 1-0 pairing implies the material world, the single unit 1 defined against the void, 0. This allows for the constant subtraction and addition of material possessions that define our transactional human life.
It's the world of things. One thing, then no thing.
Precisely. And finally, group 4, demon. The assigned binary is 00(1), which is the code for +3. The focus is on 2 ones, represented as I(1)1.
And this corresponds to the Sudras, or labor class, associated with service and physical work.
Yes, but philosophically, that 11-1 pair implies a duality of action, or perhaps an intense focus on material existence that leads to the inevitable divisions and conflicts that define the demon entity. 2 separate ones, not a unified whole.
So this intricate structure uses the foundational building blocks of our digital world 000000001000011 to establish a comprehensive, almost caste-like social and spiritual hierarchy.
It suggests that the inherent mathematical nature of reality dictates the class structure of the universe. It's not arbitrary, it's coded in.
The conclusion drawn from the system is, it's just staggering. The theory posits that, quote, 4 kinds of people live in our universe based on this digital classification: the Guru Brahmin, the God Kshatriya, the human Vaishya, and the demon Sudras.
And the final point he makes is that all have their own world to live independently, just like Earth is made for only humans.
Our technological reality, defined by subtraction in that 1-0 pairing, is just a subset. It's merely one reality out of 4, a human world operating on human rules with human computers built on subtraction.
It's a complete unification theory. Every aspect of existence, from our commerce to our cosmology, must adhere to its assigned mathematical operator and its assigned binary signature. The simple, weird act of 0, 1 equals 0 becomes a foundational spiritual truth for our specific reality.
Okay, let's try and wrap this up. We began this deep dive with a text dedicated to Lord Shiva and the pursuit of a monastic life. We navigated through these esoteric self-help precepts. We meticulously broke down 4-bit binary tables using unique, non-traditional arithmetic rules.
And we landed firmly on a cosmic and social classification system that's based entirely on digital arithmetic.
The profound implication of Chapter 27, I think, is that it forces us to see even the most foundational elements of our modern world, the 0 and the 1 of binary code, not as neutral technological components.
No, not at all. It presents them as elements carrying deep philosophical and spiritual alignment. It asks us to consider if technology itself is aligned with a specific spiritual or social purpose, based on its underlying mathematical operations.
The internal logic of the computer is a reflection of the human condition.
That's the takeaway.
We saw that the human class, our class, operates on subtraction, and its binary focus is 1 and 0 as 1, 0, which is the code for +2. And this structure is proven, at least within its own axioms, to work perfectly for our reality.
So if we connect this back to the author's strategy, the idea that these questions are rough guides for experts to achieve perfect results, this raises a really important final thought. A thought for you, the listener, to explore.
Go on.
If our computer rules are fundamentally human rules, following the logic of subtraction, what would a digital world designed around the guru's operation look like?
A world based on multiplication with a focus of 0, 0.
Or the demon's operation, world of division, with a focus of 11, 1. Their basic rule operations would have to be fundamentally different from our 0, 1 and 1, 0 equals 1 axioms.
So what are the equivalent multiplication or division rules between 0 and 1 that would generate a functioning digital reality for them?
That is the next level of complexity this text invites us to explore. It suggests that computation itself is merely a reflection of the cosmic entity that is using it. And that is a thought to chew on.